Homework 3.2, Polynomial Functions, Video 2, homework due Wednesday, May 27th, 2020 at 11:59 p.m. The following video is associated with homework questions 1 through 4 directly and 10 through 12 partially. Well, let me rephrase that. 1 through 4 completely and 10 through 12 partially. In other words, questions 1 through 4 are just like this, and questions 10 through 12 contain a part that is like this, but there is more to 10 through 12. So from this point forward throughout this series of videos, when I write problems out of parentheses, that means that the homework question is just this. And when I write problems in parentheses, that means the homework question includes this and more. All right, so we're going to take a look at what's called end behavior. In the previous video, we mentioned that for a parabola, the ends are predictable. Either both ends rise if the leading coefficient is positive, or both ends fall if the leading coefficient is negative. However, there are 4 combinations of end behavior as I have illustrated here. For example, this first graph, we would say on this one that the left rises, the left falls, because the left end points down, and the right rises, because the right end points up. On this one, since both ends point up, we would say both ends rise. Actually, I believe the wording in the homework is it rises to the left and it rises to the right, but it'll use the word rise or fall. On this third one, we have an example of the left rising, so the left rises and the right falls. And in this last one, we have both ends fall. Now, we haven't actually done the problem yet. I'm just explaining how to describe what the ends of a graph do. You say you say rise or fall, depending upon which ends point up or point down. So if an end points down, such as here, here, or here, you say that that end falls. And if the end points up, such as here, both of these, and here, then you say that that end rises. So our goal in this video is to try to predict in advance what the ends of the graph will do based on the function itself, and then use that information to help sketch a graph. I'll go ahead and tell you right now that the 4 graphs over there are the 4 graphs of these functions. You can use graphing technology to verify that. I recommend Desmos.com if you don't have a graphing calculator handy. I did not graph those using technology. I graphed them in my mind using techniques I'm going to show you in this series of videos. So by the end, we'll be able to manufacture those graphs manually without the need for a calculator. But what I really want to do is try to figure out what do you look for in these functions to determine what the ends of their graphs will do. This is the graph of f of x. This is the graph. They're in the same order, A, B, C, and D. So where do we look to determine end behavior? The answer is in the leading term. I don't think I've actually defined a leading term. Here I have the definitions for degree and leading coefficient. But the leading term is the term with the highest power. The term with the highest power. And it is typically at the beginning of the polynomial function. It doesn't have to be. If I wanted to be tricky, I could mix them up and you would have to go find the leading term by looking for the one with the highest power. But in this case, they're all at the beginning of each polynomial function. All right, so to determine end behavior, you have to look at the leading terms. So I'm going to go to each of these and put a box around this leading term. X to the 3rd power, x to the 4th power, negative x to the 5th power, and negative x to the 4th power. And within each leading term, you look for 2 characteristics. The first is whether the degree is odd or even. Now the degree will always be a whole number, so it'll be positive by default. So we don't have to ask, will the degree be positive or negative, because it will always be positive. But you ask yourself, is the degree odd or even? That's question number one. Question number two concerns the leading coefficient, the number in front of that x, and whether it's positive or negative. Now, for the sake of brevity, for the duration of these videos, I'm going to abbreviate the phrase leading coefficient with a capital LC. That way I don't have to write the phrase out over and over again. So the second question you ask is the leading coefficient positive or negative? And your answers to those two questions will point you to the correct end behavior for the function's graph. But which answers tell you which graph? Well, let's focus on each answer and the pair of graphs that have that. For example, let's look at the ones where the degree is even. So that would be B, whose degree is 4, and D, whose degree is also 4. And let's take a look at their graphs and their end behaviors. On B, where the degree is even, it's 4, both ends rise. And on D, where the degree is 4, both ends fall. So what's consistent when the degree is even? Answer, both ends do the same thing. Does that mean when the degree is odd, the two ends do opposite things? Let's check. The odd degree polynomial functions are A and C. This degree is 3, this degree is 5. And if you'll notice, when the degree is 3, the ends are pointing in opposite directions. And when the degree is 5, the ends are pointing in opposite directions. Now, it's bad science to draw a conclusion from two examples, but I can prove that that will always be the case. I'll spare you the proof. So, if the degree is even, the ends will be equal. They'll either both rise or they'll both fall. And if the degree is odd, then the ends will be opposite. So that's good information. So let's say this. If the degree is even, that means that we have equal ends. And what I mean by equal ends is that they point in the same direction, so either both rise or both fall. And if the degree is odd, that means you have opposite ends. Meaning that one rises and one falls, such as here and here. And by the way, if you're into alliteration, which is a literary device, even and equal both start with E, odd and opposite both start with O. So even degree, equal ends, either both rise or both fall. Odd degree, opposite ends. One rises, one falls, either like this or like this. Okay, well that's good, but that doesn't narrow it down. Because if the degree is even, I know it's one of these two cases, but I don't know which one. This is where the answer to the leading coefficient sign comes into play. So let's see if we can figure out what's going on with the leading coefficient sign. And let's do it by comparing graphs whose leading coefficients have the same signs. For example, in A and B, the leading coefficients for both of these are 1 and they're both positive. So let's look at their graphs and see what they have in common. What do these two graphs' ends have in common? The right ends both rise. The left ends do opposite things, but the right ends both rise. Does that mean when the leading coefficient is negative? Well, let's see. Here's two polynomial functions whose leading coefficients are negative. They're both -1. Let's look at their graphs. And what do they have in common? On both of these graphs, the right end falls, So what we seem to discover here is when the leading coefficient is positive, the right end rises, and when the leading coefficient is negative, the right end falls. We can go with that. And to say positive or negative, we'll just compare to 0. So if the leading coefficient is greater than 0, this implies, and by the way, this arrow in the part of math called symbolic logic, this arrow represents the word implies, meaning if this thing happens, then we can draw this conclusion. So if the degree is even, then we can conclude that the ends are equal in terms of direction. If the leading coefficient is greater than 0, like it was on these two, then we can conclude that the right rises. But if the leading coefficient is negative, less than 0, such as these two, then we can conclude that the right falls. And this is enough information to determine the end behavior, because the leading coefficient will tell us what the right side does. In other words, if it starts positive, the right point's positive, and if it starts negative, the right point's negative. And then the degree will tell us whether the left end is equal to or opposite of the right. So for example, if we were analyzing this one, we would say, because the leading coefficient is negative, the right falls. Because the degree is odd, the ends are opposite, so the left must rise. And it does. Or, if the leading coefficient were positive, that would mean that the right rises. And because the degree is even, that means that the ends are equal. Both ends rise. I will warn you that if you click View an Example, it will show you a different approach to determining end behavior. It's consistent with what I've shown you. In fact, this video, although it's over 10 minutes, I'm going to show you what the book shows you. It's not wrong, but to me, it's just a lot of random stuff to memorize. And if you look for patterns, this will emerge. But I can't stress enough that in my personal opinion, as both a mathematician and a math teacher, this is the easier approach to determining end behavior. Because of the alliteration here, even degree is equal ends, odd degree is opposite ends. And then remembering that the first number's sign, the leading coefficient sign, tells you what the right end does. In the book, however, they'll show you this. Basically, what they do is summarize everything in a table based on whether the degree is odd degree, even degree, and based on whether the leading coefficient is positive or negative. So it's still the same criteria, but what the book will say is this, and I'm going to say it fast to let you on purpose. If the degree is odd and the leading coefficient is positive, then the left falls and the right rises. But if the degree is odd and the leading coefficient is negative, then the left rises and the right falls. If the degree is even and the leading coefficient is positive, then the left rises and the right rises. So both ends rise. But if the degree is even and the leading coefficient is negative, then the left falls and the right falls. In other words, both ends fall. So the textbook's approach to remembering this is remember this. And to me, that's just a bunch of random assortment of words and symbols. Unless you start digging for patterns, and it doesn't take long to find them. Look, when it's odd, these are opposite, and when it's even, they're equal. When the leading coefficient is positive, the right rises, and when the leading coefficient is negative, the right falls. So I prefer, personally, asking these two questions and knowing what the answers say, as opposed to just memorize that table. In the next video, we'll answer some more questions about what's the end behavior, but when our functions look a little different. You'll see what I mean in a moment. I said stop.